All right, so here's an example of how we can use what we know about the derivative of sine and cosine now to find other trig functions, right? Because if we look in our trig cheat sheet, we have our reciprocal and also co-function identities, where we can get any trig function in terms of another, and so and really we can get any trig function in terms of sine and cosine, right? Because we know from our trig cheat sheet that and let me just show you that real quickly. So for example, and this is straight from your trig cheat sheet, tangent is sine over cosine, right? So if I rewrite this as sine over cosine, this is something we can, fairly easily do, right? This is a pretty straightforward problem. We have our derivative, our numerator function, our denominator function. The derivative of our numerator function is cosine, right? The derivative of our denominator function is negative sine. And so now we can just use the quotient rule, right? So f prime of x would be f prime cosine times regular g, all right? And then minus g prime, which is negative sine, over, multiplied by regular f, or the original f, which is just sine of x, and then all over the denominator, and we'll just write it this way to start out, but the denominator squared, right? The denominator function squared. And so we'll have cosine times cosine, cosine squared. And then here we have a negative negative, so it turns into a positive. Sine times sine is sine squared. And then on the bottom we have cosine squared. All right. Now there's a couple different ways we could go with this, but we know that whenever you have sine squared plus cosine squared, that equals 1. And that's like, if you remember one trig identity, well, there's a couple like this. This is a good one to remember, the tangent identity. But probably the next one, and this is a little bit on the trig on your trig cheat sheet, is just a little bit further down the list. But you'll see sine squared plus cosine squared equals 1, and so this equals 1, right? So that's how I get this 1 here, and then I just have cosine squared on the bottom. And 1 over cosine is equal to secant, right? And so that means 1 over cosine squared is just equal to secant squared. All right, so what we just proved is we proved that the derivative of tangent is secant squared, okay? So if we take d dx, the derivative of tangent, that equals secant squared. All right, so we just proved a derivative there. All right. And we could do the same thing with cotangent, which is something you may be asked to do on the assignment. Or maybe I'll ask you to do it right now. So first of all, what I want you to do is tell me what cotangent equals in terms of sine and cosine, right? So look on your trig cheat sheet and rewrite f of x in terms of sine and cosine, because we know the derivatives of sine and cosine, right? You could actually also go with this, since we know tangent now. You can actually use the reciprocal identity and just do 1 over tangent and then do the quotient rule with that. But let's go in terms of sine and cosine, since that's what we've been we're a little more familiar with. Okay, so write that out. All right, and if you put cosine over sine, you're exactly right. Okay, so now let's find the derivative of the numerator function. Right, negative sine. The derivative of the denominator function is cosine. Good job. And so now we can set it up. So our derivative with using the quotient rule is going to be f prime negative sine x, and I don't know why I put theta here, but It should be x. And sometimes you might see d theta. You might take a derivative in terms of theta, but all right. And so yeah, so this is f prime g minus f, which is cosine, regular cosine, or g prime is cosine, right? Times regular f, which is also cosine. All right, so let me just write this out just in case I mix anybody up there. So f prime g and then g prime f, all over g squared. So I'm going to have sine squared of x. So here what happens is we have negative sine times sine, which is negative sine squared. And then we have negative cosine times cosine, which is negative cosine squared. And on the bottom we have sine squared. Okay. Once again, you could break this up, but actually I could factor out a -1 here, right? And this would give me sine squared plus cosine squared. And we know that sine squared plus cosine squared equals 1, right, from our Pythagorean identity. So we just have -1 on top and then sine squared on the bottom. All right, and 1 over sine is equal to cosecant. And so this just equals negative cosecant squared x. And so that's what the derivative of cotangent equals. So the derivative of cotangent is equal to negative cosecant squared x. All right, so by using trig identities, we can find derivatives of other trig functions, right? So it all starts with sine and cosine, and we had to do that either, kind of with our limit definition and either graphically or with tables or intuitively. We're able to find that, and then once we were able to find sine and cosine, then we can find all the other trig functions, because we can get all the other trig functions in terms of sine and cosine, as you can see with our identities here that we have on the right. So we use an identity to start with, and then we use an identity once we got our derivative kind of simplified. We use another identity, and that got us down to our single trig function value answer, which is negative cosecant squared x, right?